Okay, 9.3. We're still talking about solving linear equations. We're going to be solving them in the format of ax plus b equals cx plus d. Go ahead and take a minute to pause this to read this information. Okay, let's get started. So on example A, you notice that we have a variable term on both sides of the equal sign. The variables are the same and they're both to the first degree. We have a constant term on both sides. What we want is to get the variable term on one side and the constants on the other. So what I want to do is get all the variables to the left-hand side. That's how I'm used to reading it. You can solve it to the right side. Just be careful with your adding and subtracting and your signs. So I'm going to subtract this 2x from both sides. My apologies, I scooted my screen over. Made the 2x go away. So now I got 3x minus 2 gives me x. Bring down the plus 3 is equal to negative 18. Let's subtract the 3 from both sides. And now I got x is equal to, well, I'm in the hole $18. I'm going to spend 3. Now I'm in the hole 21. Let's do the same here, but we got a little bit more going on. If you notice on this side of the equal sign, we have like terms. So we need to put those together before we start moving across the equal sign. On this side here, we got like terms. So we need to put those together before we start moving across the equal sign. So let's do 4y minus y gives me 3y. And let's bring down the plus 1 is equal to, let's bring down the 2y. This negative 13 plus 5 is like saying I have $5 that I spent $13. So now I'm in the whole 8, right? Now let's scoot across the equal. I'm going to take this 2y, it's positive, so I'm going to subtract it from both sides. Now I got 3y minus 2y is y. Bring down the plus 1 is equal to negative 8. I want y by itself, so I'm going to subtract the 1 from both sides. Now I got y is equal to 8, negative 8, minus 1 is negative 9. Let's do F. Okay. Any of these, though, that I'm not doing, if you'd like to see them worked out, just reach out to me. I'm just trying to pick the ones a little bit more work required. All right, so I have a lot going on. So I can put together these like terms before I start moving across the equal sign. I can also say, hey, wait a minute, I got fractions. I want to undo the fractions. And the fraction has 2, 4, and 3 in it. So I know the least common denominator here is 12, right? So if I multiply each term by 12, what happens? I get rid of the fractions. Now, don't get me wrong, the end answer may come back to be a fraction, but the adding and subtracting will be a little bit easier. 2 goes in itself once, goes into 12 6 times. Now I got 6 times 1x is 6x, plus 4 goes in itself once, goes into 12 3 times. Now I got 3 times 3x is 9x, all equals. 2 goes in itself once, goes in 12 6. I got negative 5 times 6 is a negative 30, plus 3 goes itself once, goes into 12 4. I got 4 times 2x is 8x. I got negative 1 times 12 is negative 12. Now let's put together like terms before we move around. So we have 6x plus 9x is 15x. And that's equal to, we have $30 and, or excuse me, we're in the whole $30 and we spend 12. That gives us a negative $42. Bring down that plus 8x. Now I'm on all the variable terms on one side, so I'm going to subtract the 8x from both sides. That leaves me with 7x is equal to negative 42, and let's divide by the 7. And now I got x is equal to negative 6. Let's do h. If you notice h, we have the distributing property going on. And if you look inside the parentheses here, you know we're supposed to do parentheses first. they're not like terms, so we can't put them together. However, we can go ahead and distribute this -2 to everything in here. Oops, don't forget our x. Bring down the parts that we have. And I didn't give myself enough room, so don't forget the -41. So should have skipped over more. So I have -2 times +5 is a -10x. I have -2 times +13, so it's a -26. Bring down the -2 is equal to, I have -6 times +3x is -18x. I have -6 times +2 is -12, all minus that 41. Hey, that worked out great. It went with this row. All right, let's put together like terms before we start scooting over. So these two are like terms and these two. So I got -10x. I'm in the whole 26 and I spent 2 more. I'm in the whole 28. Bring down the -18x. I'm in the whole 12, right? And I spend $41. So now I'm in the whole 53. Now let's get all of our variable terms on one side. So this is a -18. I'm going to add it to both sides. That went to 0. I'm going to go ahead and add this 28 to both sides, make it a 0. So now I got 18 minus 10 gives me 8x. That's equal to, we have 28 minus that 53. That is a -25. And then we're going to divide by 8. And this is going to be fraction form because 25 is made up of 5s and 8's made up of 2s. So we are left with this as our final answer. So next we're going to talk about conditional, identity, and contradiction. Conditional means that we're going to get a variable actually equal to some number. So it's conditioned at that particular point. Identity means we're going to get something that's equal to itself. Right? It's an identity because it's equal to itself. Contradiction, 8 does not equal -3. Right? 2 does not equal 0. So that's a contradiction. So let's solve these. A says we have 3 times this parentheses, and inside that parentheses does not have like terms, so I cannot combine them. So I'm going to distribute the 3. So I have 3x, right? 3 times x. Now I have +3 times +5. Bring down the +1 is equal to -11. Now I have 3x plus 3 times 5 is 15 plus 1 is equal to -11. I have 3x, 15 plus 1 is 16 is equal to -11. As y'all can see, we're going to have a conditional here, but we need to state when it's conditioned at. So let's subtract the 16 from both sides. It's like saying I'm in the hole $11, spent 16 more. Now I'm in the hole 27. I have a +3 coefficient on x, and I need it to be a +1, so let's divide by 3. So now I have x is equal to -9. This is conditioned at when x equals -9. Let's do B. B says we got this 3 multiplied to this parentheses, and in the parentheses they're not like terms, so we can't combine them. Then I have this 6 times these parentheses, so let's go ahead and distribute. I have 3 times y. I have a +3 times that -25. Bring down the +3y is equal to 6 times y plus 6 times 10. So now I have 3y is equal to didn't mean to say equal, my apologies. We have the +3 times -25, which is a -75. Bring down the +3y. Is equal to 6y plus 6 times 10 is 60. Now let's put together this 3y and 3y because they're like terms. 3y plus 3y is 6y minus 75 is equal to 6y plus 60. And I wonder if you see what's going on. We need the variable terms all on one side and the constants on the other. So this 6y here is positive, so let's subtract it. And what happens? Our y's go to 0 and leaves me with negative 75 is equal to 60, and that's not true. So this is a contradiction. Okay. Let's do one more. Let's do C. I'm going to distribute the negative 2 to everything in that parentheses. So now I got negative 2 times t. I got negative 2 times that negative 7. Bring down the plus t, it's equal to 14 minus t. Negative 2t. Negative times negative is positive. 2 times 7 is 14. All right. Let's put together our like terms. I have negative 2 plus that negative 2t plus that t gives me negative t plus 14. We don't have to do anything else because if you notice, we got a negative t on both sides, a positive 14 on both sides. This is an identity. All right. Our last one. Bob's shoes and shoes are both interested in renting equally sized buildings for their shoes or for stores. Okay. Bob needs 1,050 square feet for the office, 800 square feet for shipping, and he needs 850 square feet of offices, 200 square feet of shipping. All right, so we have a lot going on, right? If I just read this and if you read it and you get confused, there's a lot going on. What are we needing? He needs a building that has 1,150 square feet office space and 800 square feet of shipping. And then he needs another building of 850 square feet of offices space and 200 square feet for shipping. So if you notice, they set it on each side of the equal sign, separating it. Now let's talk about the 4x and the 10x, where that came from. If Bob's shoes require 4 square feet per package box, right? And that went with the first one. And it requires 10 per box. How many boxes will he need? So that's where the 4x and the 10x came from. And the 4x went with the first scenario and 10x went with the second one. So now what I want to do is I want to put together my like terms. So we got 1,150 plus the 800. That gives me 1,950 plus that 4x. That's equal to 850 plus 200, which is 1,050 plus 10x. Now let's get all of our variables on one side or constants on the other. So I'm going to subtract the 10x from both sides. And I got 1,950 plus, it's not a plus because it's a negative, right? So it's a negative 6x. Because if you only have $4 and you spent 10, you got a negative, right? And that's equal to the 1,050. Let's subtract the 1,950 from both sides. Let's rewrite it where it's a little bit cleaner. So I got 1,950 minus that 1,050. It's 900. And it's a negative, right? Now let's divide by the negative 6 because we want a positive 1 coefficient on x. So 900 divided by 6 gives me x is equal to 150. And that's what we need.